Hello students, so we have been discussing about some of the important compounds of boron. So there now we discussed about diborane, their structure, their uses. Then we discussed what is now this borazine. We discussed about borazine as well. So now let us discuss another important boron compound that we will call orthoboric acid. Orthoboric acid having a molecular formula H3BO3. So this is orthoboric acid. Sometimes we write like this BOH thrice, having 3 hydrogen, 3 oxygen, and 1 boron. So that is orthoboric acid for it. Okay, so another important boron compound. So first let us discuss the structure. Okay, it's 3BO3. This is the one of the formula of the orthoboric acid. How the structure will be. The important point you can learn about orthoboric acid now. Each H3BO3 units are connected each other by intermolecular hydrogen bonding. So that's how the structure you have to think. So basically, it's like a BO3 trigonal planar structure where each oxygen having a hydrogen, right? So let me write like this: hydrogen and hydrogen, and this is the one H3BO3 unit, and which is connected to other H3BO3 unit by intermolecular hydrogen bonding. So that's the point you can remember. So let us think how it will be. This will be connected to hydrogen, and you can see, and there will be another oxygen will be there, and that's connected to other BO3 units, where this BO3H unit having one hydrogen which is represented here, and this oxygen and this hydrogen are intermolecular hydrogen bonded. So this is the one BO3 unit, another BO3 unit are hydrogen bonded. So that's the way now the structure will go. That's the way you can imagine this is another unit. So this is the voice, this is the voice. So that's the way the structure will now develop. So each BO3 units are triangular planar structure, and two units are interconnected or they are attracted each other by intermolecular hydrogen bonding. So that's the way the structure of H3BO3 will develop. Okay, that's the point you can learn about orthoboric acid. Now let us discuss what's the structure, discuss the structure. Now let us discuss how the preparation. Let us discuss the preparation of orthoboric acid. First one from borax. Borax having a molecular formula Na2B4O7 10H2O. This is the molecular formula of borax. So borax is another important boron compound. So borax, when not boiled at in presence of concentrated hydrochloric acid or sulfuric acid, you're going to get orthoboric acid. So that's the important point you can remember the method of preparation from borax. Borax, when heated strongly, means not 10 molecules of water that will be eliminated. So you will get Na2B4O7, which will react with the hydrochloric acid, or no, you can imagine sulfuric acid. In presence of water, you getting a orthoboric acid. So one of the method of preparation where sodium chloride is also getting as a side product. Okay, if you correct the for molar ratio, it will be 2 moles of HCl will be reacted, and you getting 2 moles of NaCl and H3BO3, 4 moles of H3BO3. So that's one of the method of preparation of orthoboric acid from borax. Borax is Na2B4O7. So that's react in presence of concentrated HCl. When they boil, you're going to get borax. So that's one method. Then next one, colmanite. Having a colmanite having a molecular formula. That's something that you have to write in practice. That is Ca2B6 O11 5H2. So this is the molecular formula of colmanite. Again, no, this is also colmonite is when treated with the sulfur dioxide in presence of water, you're going to get orthoboric acid. So when this is heated, the 5 moles of water will be eliminated. So you're going to get Ca2B6O11 plus in presence of water 11 moles of water plus 5 moles of sulfur dioxide. So sulfur dioxide gas is passed through the hot solution. You're going to get two products, one is calcium bisulfite, CaHSO3 twice. Calcium having a charge plus 2, bisulfite it will be minus 1. So calcium bisulfite plus orthoboric acid. So that's a method of preparation of another method of preparation of orthoboric acid from gold monite. Okay, something that I have to write and practice. Next one from boron compound. Similarly, boron halide, boron trifluoride, BF3. When it's reacted with water, you're going to get orthoboric acid. Also, another important boron compound that we call fluoroboric acid. Fluoroboric acid and orthoboric acid. So this is the product that you're going to get when boron trifluoride, one of the boron halide, when reacted with water, in presence of water, you're going to get orthoboric acid and fluoroboric acid. So that's the important three methods of preparation of orthoboric acid that you can remember. The formula is H3BO3. Okay. Now talk about properties. Yes, talk about properties. Now they are solids. They are orthoboric acid are white crystalline solids, which not having having a soapy like of a texture. When you touch it, now there is soapy kind of feeling. So they're soapy to touch, and they are sparingly soluble in cold water, and it's soluble in hot water. So that's a point you can remember about orthoboric acid. It's a first point is a weak acid. Okay, not a strong acid. Then it's sparingly soluble in cold water, sparingly soluble in cold water, and soluble in hot water. Okay, let's talk about properties of white crystalline solid. White crystalline solid. Okay, so these are the points you can remember about physical properties. Now let us discuss other important properties. We'll talk about acidity. Yeah, orthoboric acid I already told it's a weak acid. Now it's not a protic acid. As a first point you can remember. Talk about now you can write this like this. It's 3BO3. You can write like this. BOH thrice. It's not a normal no protic acid. Let's talk about protic acid. H2SO4 is a protic acid. When dissolves in water, it releases 2 moles of H plus ion and sulfate ion. So that means no, it's a protic acid. It releases H plus ion. But it's not in the case with the orthoboric acid. It actually is an acid because no hydronium ion is releasing, but we expect 3 moles of H plus ion to release, but it's not. What's happening here is actually it reacts with water where no lone pair of electron attacks the electron deficient boron atom. So we know boron compounds are generally electron deficient compounds, so they are Lewis acid. So here the lone pair of electron attacks the boron atom and you getting BOH 4 times tetrahydroxyl borate plus hydronium ion will be released. So by the reaction of water, tetrahydroxyl borate will be formed. By the time you can see a hydronium ion will be released. In that sense, it's yes, it's acidic but not a strong acid. Tetrahydroxy borate. It's not a normal kind of a reaction that you will observe in other acids where when such strong acid when dissolves in water you can see how many H plus ion is there that will be released, but not this case. Here lone pair of electron oxygen attacks on the electron deficient boron atom to release 1 mole of hydronium ion. In that sense, it's acidic but not as strong acid. It's a weak acid. Similar no reaction with sodium hydroxide. Strong alkali supports no its acidic behavior. When NaOH, sodium hydroxide react with orthoboric acid, you're going to get NaBO2, sodium metaborate. Sodium metaborate plus water will be released. So that's a reaction with the alkali. When acid and base form, you can see salt and water will be formed. So boron salt will be formed, sodium metaborate, and the water will be released. If you take higher molar, 2 moles of NaOH, when react with the 4 moles of hydroboric acid, you getting a sorry, this is no orthoboric acid. You will getting Na2B4O7, sodium tetraborate plus water will be released. You can see now salt is forming, but this time no sodium tetraborate. When now 1 mole of NaOH and 1 mole of orthoboric acid reacts, you can see sodium metaborate will be formed. But higher now moles you take, 2 moles of NaOH and 4 moles of orthoboric acid will give you sodium tetraborate. So that is the acidic nature that now you can see in orthoboric acid. It's a weakly acidic, it reacts with the base and it releases hydronium ion when dissolves in water. In the case now, a lone pair of electron attacks on the electron deficient boron atom and forming a tetrahydroxyborate. By the time you will see a hydronium ion, 1 mole of hydronium ion will be released. So it's acidic, not strong acid. Similarly, action of heat. When orthoboric acid is heated, what will happen? When orthoboric acid is heated strongly at 100 degrees Celsius, you can see metaboric acid will be formed. HbO2, metaboric acid will be released and water will be formed. So this is what happened. This is what happened when orthoboric acid is heated at 100 degrees Celsius. Again, now this metaboric acid, when heated to higher temperature, that's now around 140 degrees Celsius, you getting another uh, boron compound that we call tetraboric acid H2B4O7. H2B4O7, tetraboric acid, and water will be released. So that's another boron compound. Again, this tetraboric acid, when is heated to higher temperature, that's no red hot. That's such a high temperature when you heat, you getting a boron trioxide, or you can say boron anhydride, or simply boron hydride, like that. Sorry, boron oxide, boron anhydride, boric oxide, or no boron trioxide. Such names are there. 2 moles of boron trioxide and water will be released. So this is the action of heat when orthoboric acid is heated at 100 degrees Celsius. First, this is metaboric acid, right? Metaboric acid will be formed. This metaboric acid on heated at 140 degrees Celsius, you get a tetraboric acid, which on again followed by heating at a very high temperature, red heat. At such a high temperature, you're going to get a boric anhydride or no boric trioxide will be formed. So this is the action of heat that now you have to learn. Next reaction with ethanol. Now this is something that you do in lab to detect the presence of borate. So this reaction is very important. So you can learn action with ethanol. Action with ethanol. So you can see the reaction when orthoboric acid, when heated with ethanol. Ethanol is C2H5OH. First, no, a C2H5 thrice BO3. The name is triethyl borate. Okay, triethyl borate will be formed. Plus, as a subproduct, water will be formed. So when this boric acid, when heated in presence of ethanol, you can see a volatile triethyl boric ester will be formed. They are volatile in nature. So when this, imagine you taken a orthoboric acid and ethanol in a test tube. When you just heated it, you can see they are vaporizing in nature. Triethyl borate will be formed. That vapors, when it's coming out of the test tube, you shown on a non-luminous flame. You can see, the edge of the test tube actually, burns with a green color. We call it as a green edged flame. Green edged flame. Now that actually tells you the compound containing a borate as an anion. So in the next year you actually do a reaction for the detection of anions and cations in a mixture where if borate is provided, this is one of the beautiful tests where now you take orthoboric acid and ethanol, you just mix it in presence of acid. Sorry, acid is also there. Concentrated H2SO4 in presence of concentrated sulfuric acid. When you heat strongly, you can see a triethyl borate will be formed. That's volatile in nature. That volatile vapor, when it's coming out, when it's shown on a non-luminous flame, you can see the edge of the test tube actually burns with a green edge flame. That tells you the presence of borate. Similarly, reaction with the calcium fluoride. When calcium fluoride react with orthoboric acid in presence of concentrated sulfuric acid, 3 moles of sulfuric acid, you can see the product will be 3 moles of calcium fluoride and 2 moles of orthoboric acid. You're getting 3 moles of calcium sulfate plus 2 moles of boron fluoride and water will be formed. 6 moles of water will be formed. So here again, now this is what you are doing. Actually, now you take a watch glass, you mix calcium fluoride, which is solid, and orthoboric acid, which is again solid. These two are now made a paste in presence of concentrated sulfuric acid. And that paste, when you shown on a non-luminous flame, you can see, the it burns with a green flame, a green flame. You will observe that the presence of formation of boron trifluoride. Okay, that again indicate the presence of borate. So that's again another important test for the detection of borates. You can use where borate and orthoboric acid are mixed in presence of concentrated sulfuric acid. You're going to get a green flame. When you shone on a flame, you will see a green flame. That's again suggests you the presence of borate. So these are the important properties that you can remember, especially the last two one. It's very important. Okay, acidic behavior also generally asked. That also important. So these are the important properties of orthoboric acids. Talk about uses. Yes, orthoboric acid has very important uses, especially in the industry, chemical industry, it has a very important role. So it's important use. If I ask antiseptic, that's something that always you have to remember. It's a good antiseptic properties is there. That why in our creams, in body lotions, everything. We actually adding one of the component as another component will be orthoboric acid. So antiseptic, anti-stringent, antifungal properties there. Anti-stringent and antifungal property. And this stringent again for it has the ability to clear some of the skin problems, some small pores or something is there, some small wounds or something is there, that can be cleared like that. No, it's a good anti-stringent, antiseptic, and no antifungal properties are there. That's why they used in skin creams, powders, and lotions, etc. So that's important first use. Again, no, it's such an important antiseptic property that now even in eye and ear lotions it actually used, that suggests you it doesn't harm in our body. So it's a no good antiseptic compound. Again, as a food preservative, that's another use you can remember. Used as a food preservative and as a pesticide. Yes, another important use, and as a cleanser, stain remover, and deodizer in laundry purpose. So that's again another use. And yes, as we expect, it's used as ingredient in the cosmetics. And next important use, heat resistant glasses used for the preparation of heat resistant glasses. Now, most of the laboratory items that you see, the glass items that you will see, generally they are heat resistant, our test tubes and our beaker, conical flask, etc. So these are now generally should be heat resistant. So for making such heat resistant glasses, now generally we call borosilicates. So for the preparation of that, we using orthoboric acid as the one of the components. So used for the manufacturing of heat resistant glasses. And still no, it has a property of heat flame retardant. That's again suggest you another important property. Flame retardant property is there. Hence is used in the manufacturing of furniture, mattress, and the insulation process. Okay. Again, another important use, neutron absorber. This is something now we study in nuclear reaction, where now it can act as a neutron absorber. But it's very important because now in a controlled chain reaction, if the number of neutrons increases, means now the reaction become uncontrollable. So for controlling the nuclear fission reaction, it's very important the neutron should be absorbed and the speed of the neutron now should be deaccelerated. So that why now the role of boron compounds is very important in a nuclear reactor. So it can act as a neutron absorber in a nuclear reactor. Another important is a precursor to other chemical compounds, including pigments. So that's something now we usually see in some chemical reaction where normally some chemical reaction is taking place, some side reaction also takes place to get some useful compounds. In that sense, no boric acid. It has a no. We already saw it as a antiseptic property and fire retardant property and neutron absorber, food preservative, pesticide. Such qualities are there. Hence, no, they generally is there in the most of the components. So it combined with some other compound to form get some useful products. In that sense, no, this orthoboric acid used as a precursor or to some other chemical compounds. So these are the important uses for boric acid, not something that you can learn. Okay, read it through. These are the not the toughest of question, but not something that you have to remember by practicing. So keep doing that. Okay, thanks for listening. Let us wind up.